Here are the 16mm tubes by 2 meters. I got my T's and my 90-degree angles, and I just found the 16mm caps. I do have solder, but I'm not sure I have enough gas, so I got some gas. Well, I do have some gas, but not that kind. And I got some gray Rust-Oleum. And I just spent about twice as much as I wanted to. Yeah. For something I'm probably going to use once in a blue moon. Oh well. Hi, this is Gilles, the radio prepper. So you guessed it, or you read the title. I'm building a new antenna. A J-pole. The J-pole is an excellent antenna. It's a vertical antenna. I have built one before, well, a few before, for 2 meters, 6 meters with a ladder line. And I want to build another one for 6 meters, 6 meters FM, but with copper tubing. Now this can be easily scaled up for CB frequencies, anything on VHF basically, and up to probably 10 meters. And the problem I encountered is that, well, they're fairly long. It's a half wave basically with a matching unit. So I think for 6 meters, the length was came to about 4.5 meters. And that doesn't fit in my truck. So I had to find a way to make it so it could be taken down. So I thought I would use, well, I have those military VHF antennas, VHF and HF. Don't quite remember the reference. I'll put it on the screen right here. And I have an original one. This one has the reference AN131FR, it's a French antenna. And this comes from Chameleon. And I think it's about 2.85 meters long, which is foldable. So that would allow me to reduce the length of the J-pole, enough to carry it, transport it in my truck. So that's kind of pretty nice. And here's the end of it. I do have the parts that screws on here, so I'm going to use that. Now we'll see the design on M0 UKD's website. He has an excellent calculator for J-poles, and that's where I'm going to find the measurements. So here's the M0 UKD website with the Slim Jim and J-pole calculator. Here we have 145 megahertz. I'm going to change that to my favorite frequency, which is 51.5 megahertz, and that of course will make for a much longer J-pole than a 2-meter J-pole. So let's submit that, calculate. All right, so yes, definitely it's actually, so A is the maximum length, and that would be 4.19 meters, 419.4 centimeters. Sorry, I'm going to stay in I'm going to stay in metric, but you can go to the website and plug in your own frequency and get your own measurements. So basically, what we have here for the J-pole is that here we have a half wave, and this part here where it's parallel, we have a quarter wave. And there is a point here somewhere just off the bottom where you have an impedance of 50 ohms. So that's what your radio wants to see. And I have found that this calculator actually works really, really well. I made a J-pole for 6 meters using ladder line, and I made mine for 2 meters, and the measurements were right on the spot. So I know it's going to come out good, and I don't really have to test and experiment. I know that if I respect the measurements, I have a very good chance that this is going to work perfectly fine. Let's check the measurements for CB. So that would be 27.2 megahertz. And let's click. And yep, that's quite a bit longer. So that's a total of 794 centimeters, so almost 8 meters long. So yeah, that would be you probably would have to make it in 3 parts to fit that in a truck, a car, but you know, for at home you could make it the full length definitely. So that would make an excellent antenna for CB. Also, no limit for the power because you don't have a toroid, so that would be you know, you could really blast a lot of power in that antenna, although I suggest you do not do that because it's really not needed, and CB amps are crap, so you don't want to use one of those either. And with this antenna, I can assure you that you're going to have very good results. You're not going to need extra power to make contact. So this one I'm making a little bit shorter at 132.5 to consider the thickness of the cap. The second one I cut at 138, so it's that much longer. That's going to be the quarter wave, and the shorter one is going to be the one that will have the 2.85 meters of the foldable antenna added to it. I am left with two shorter tubes here, and the shorter one is going to be used to cut the transverse bar at the bottom. The longest one will be used as a sort of a handle at the bottom of the antenna, or to attach it to something. It will be the length doesn't really matter, and it will just be to hold the antenna, attach it to something. And here's the bottom transverse bar, 10.5 centimeters. The only thing I have left from my two 2-meter tubes is this tube, about 20 inches long, and that's it. Everything else is used. I've made some progress, but this soldering does not look good, and I'm having a hard time to get a high enough temperature for the solder to flow in the joints, and I'm really worried about that. But I don't have a bigger torch, and that's really what I should have bought, but I didn't have the money. I already didn't have the money to buy all that stuff. So hopefully that's gonna hold. We'll see. Hopefully that's good enough. Alright, let's design the feed point box using Tinkercad. So I'll start by making a cylinder. And let's say, okay, 30, okay, that sounds reasonable, 30 tall. We want it to be bigger. I want about 4 millimeters around the tube, so I will say 16 plus 8, that's 24. Now I want to make a hole in this, but before that I'm going to actually double it, because of course we have two tubes. So here, duplicate, and I'm going to slide it 12.4 millimeters away. That's because we have 12.4 millimeters from center to center. So 124, 24, making sure it's on the same line. Perfect. All right, so now we can make the holes. I'm going to make them slightly bigger than the tube, so I can actually slide the holes in the tubes, or rather the tubes in the holes. And I'll make them 16.6. So it's going to be fairly tight, but it should work fine. That's what she says. All right, so 16.6, I'm going to make them taller, of course, to make a hole, and I will duplicate that because we need 2 holes, of course. And here we go. Let's center that. And make sure it goes all the way through. Same thing on the other side. Center and lower. Alright, so now we want some kind of a box in the middle here. The thing is that I will have to make something that I can open, and or maybe I can make a cover. That's an option. That might be good, but well, of course it has to be closed on the top here, so I'm gonna have to make something that I can print on the side. So I'll have to cut this in half and then double it. All right, so let's see what can I do. Let's take this. That will be the center. So we have we'll make it actually 124 wide, so that it goes from the center of one to the center of the other. 124. We'll make it the same height, so 30. And what else? Is it 24 wide? I want it to be 24 wide. 24. And of course, if I place that in the middle here, it should just be perfectly aligned. Yep. So that's good. That's what I wanted. But of course, we want a box. We want a box. So we have 124 from center to center. Then we have 24 diameter for the for this. So that's 12 is a half. So I will want to make a hole here to make a box. But should I maybe... I wonder if I should split that before, but probably not. It's not a good idea to split it at this time. But I want it to be a box. I can make it a box. Okay, let's think carefully about this. I'm going to need a hole. And this hole, I want the walls to be 3 millimeters thick. So I'm going to make it 6 millimeters shorter for the height, and that will be 30 minus 6, that's 24. Okay, good. Now I want, let's see, what do I have? 124 here from center to center. 124 minus, well, minus 24, right? Duh. Okay, so that's 100. Whoops, 100. Okay, so do I have that right now? Oh, the width. The width is 24, so if we want 24 minus 6, that's 18. So we want that to be 18 wide. Okay, so that should go in the box here. But I'm going to make it 3 millimeters from the bottom. Now I'm going to group the whole thing. Align. Alright, so we have to align it from all possible angles. So let's see. This is going to be tricky. Done. Well, I don't see it anymore though. That's the problem. It's gone. Oh geez. Okay, here I guess. No, because it. Why did it? Oh yeah, I moved it to the top. That's not what I wanted to do. So middle, middle. Is it exactly in the middle though? Oh, you know what? I can make this like transparent. We can verify that it actually works. Okay, so all right, it seems to be centered here. It's certainly centered right there. So we have basically a hole inside my solid here. Is it centered this way? Yes. Okay, so I can group both of them. And now we have, well, we can't see it, but we have a solid with a hole in it. I can, well, let's just, I can make it solid again. Not transparent. Okay, fine. Whoops, center it right there. Does that look all right? No. Okay, and that should be centered. It certainly looks centered from center to center. Alignment. Well, problem is that I don't want to center everything, so I have to be careful here. I can check visually, see if it's okay. It looks all right from this angle. Yeah. All right, I'm going to group the whole thing and hope for the best. Okay, so we have now our piece here, center piece, and we should have a hole, a void in the middle. Now, how can we check that? Well, that's simple. We're going to make a void here. And we're going to make it 30 tall, same thing. Actually, we could make it taller, doesn't really matter. Yeah, we can make it, no, whoops. 0, 0, oh, we can go minus 4, okay, and I'll make it taller. All right, and what I want to do now is to cut half of this, of our part here. And well, I'm not sure I'm in the middle, but I can. It looks, well, no, maybe not. Done. I'm not sure I'm in the middle here, so I'm going to move it to the edge. All right, I'm at minus 11, so it's how wide is it? Isn't it 20? Yeah, it's 24 wide. So I have to move 12. Whoops, and here I'm at minus 11, so that should be plus 1. All right, that looks centered. Yeah, okay. Let's group it. Now, let's see if it worked. No, darn. My void is gone. Why is that? It didn't work. Maybe because it was inside when I grouped the two parts. All right, let's do this another way. We can do this another way. All right, so let's do that again. Okay, so 30 tall minus 624. 100 wide. That's what we had, right? Yep. We make it 3 from the bottom. Now we're going to make it, let's see. So we want, let's see, so that's 12 millimeters wide. Minus 3, that's 9 millimeters. I think. So we will have a 18 millimeter available total. I hope that's enough to host the BNC. All right, there we go. All right, so group that center. It's centered that way, centered and centered. No, I didn't want to center it. I do dumb things sometimes. All right. Where is it? Where's my void? Okay, we're gonna have to separate them. Go back. Okay. All right, looks good. But it's not on the edge exactly. So let's put it exactly. Whoop, here we go. And that should be. Yeah, that's centered. Okay. All right. Group. Now we have a hole. All right, now we need to put that on its side. Oops, no. Darn. Ah. I'm going to do it manually, so 90. Oh, no, it was minus 90. Okay, there we go. Minus 180. All right, looks good. Now we have to lower that to make it to 0. Oops. Minus 0, I guess it doesn't matter if it's minus or plus 0. Now I need to duplicate that. Duplicate. Well, I have to make a hole first. That'll be easier then for later. So I'm going to, and that's a hole just for the wire, which will be soldered on. But the thing is that, yeah, it has to be able to just, this will be glued. So the BNC will be in there somewhere. So I'll have to make a hole here. So I need to duplicate before making the hole, because there will be, of course, only one hole. So that we have 18 millimeters for the BNC. I think that's going to be just enough to clear, to host the BNC, and not a millimeter more. All right, so we need some kind of something for the wire to go through here, for the wires, both wires. And I'm not going to make that too small because there might be some solder, residual solder basically. So I'm going to make that 124 tall. Why not? Center to center. Now I'm going to tip that this way. Oh no, I probably should size it before. And I'm going to make it, let's see, it's 9, is it 9 millimeters? I'm going to make it 8 millimeters. Hopefully that'll work. Okay, how do I access this? Okay, 8. Now we're going to tip that on the side, 90 degrees. Lower that. Put it pretty much here. Is that in the center? I don't know. All right. Probably should put it a little higher. That sure looks better. It doesn't touch the bottom, so why not? Okay. Not touching anything else. That's good. I will center it. So center, no, not this way. Center this way, I guess. Yeah, okay. and group that. Okay, very good. Now we have a space for the wires for the connection, for the feeding point. Now I can group that. No, not group, duplicate, sorry. And put it right there. Very good. Now we have our two parts that are going to be glued together. I probably should put some kind of something in the middle here to help the gluing, because there isn't much surface here for the epoxy. Although, no, I shouldn't worry about that, because this is going to be glued as well. So there is quite enough surface here, no problem. Alright, so a hole for the BNC. So that should be a 9.5 millimeter hole. We can do that. Of course, only one hole on one of those pieces, and that's it. Let's center that. Center, so center this way and center this way. We lower that, make sure we make a nice hole. We group it, and we have a hole. And that's it, that's our center piece. Now I'm going to put that in Cura. So export to STL, and that's my JP6B. I did make another part for the upper part, well, to join the two parts a little bit higher for a little bit more rigidity, and I'm going to 3D print that. Of course, it's not coming up right now. So here it is, and that's upside down. The void here will be pointing down basically, and that's just basically just a brace to make sure that the two tubes don't move. You know, it's just gonna make it a little more solid, basically, a little stronger. Now I'm in Cura. I'm going to import my files, so I have two files to do, but I'm just going to show you the one we just did, and I'm going to print that in PLA+. So the settings, okay, so everything looks fine here. I don't think it needs support. I think it will print just fine like that. Although, I guess I'll just put support. Anyway, so quality 0.2 is fine. Going to go down. So all that's already set. Those are the default settings. Infill, I want that to be a bit stronger here, so I'm going to put 40%. Connect infill lines, yes. Randomize infill start, yes. That will make the piece stronger. The settings for this filament are already set, so I'm fine here. A retraction, yes. Print cooling, yes. 50%, yes. Support, I guess. Yeah, let's put support. Darn it. There won't be much anyway. I'll just have, that's where the red is here, and right there. So there'll be a little bit of support, but not much. But it would make a better piece, a little rounder. I'll just have to spread a little bit of sandpaper to it later. Just clear it. All right. So 47 degrees, yes. Everywhere, yes. Skirt is fine. I don't need a brim for this, and let's see how long that will take. 6 hours 33 minutes, 54 grams of filament. Very good. Save to disk, G-code, okay, save, and we're done. Now I just have to put it in the printer. Alright, because this website does cost me much more than what it brings me, I did sign up for an affiliate program with EMP Shield. We are all concerned about EMPs, electromagnetic pulse, especially for radio equipment. And EMP Shield does provide protection for your whole home, for your vehicle, and for your radios. Yes, for your antennas. I was a bit skeptical, I have to admit, but after looking at all the documentation they have and the military testing they did, and those devices they offer are extremely fast to protect you against EMPs, but also, of course, lightning. So it does look pretty legit to me. I got you a coupon for $50 off at EMP Shield, so don't forget to use it. It's Radio Prepper in one word, all lowercase. By the way, do use the link down below rather than going to the site directly. That gives me more brownie points, and you do save $50 and I get a kickback. So don't hesitate to have a look at their website. I am learning more about it myself and all the products that they offer. And I'll tell you, the way the world is going right now, I think it's a good precaution. The solar cycle is coming back and there will be a lot of solar activity. So we could get a natural EMP, that's always a threat. And you want to protect your electronics. Your toaster, your washing machine, your oven, everything that has an electronic chip in it is at risk. And you need a device that's fast enough to ground everything in nanoseconds so that when the power comes back, you still have your electric and electronic devices. Once again, the coupon is Radio Prepper, one word, lowercase, and that will give you $50 off. I'm going to make the holes for the feeding points. I made a hole into this cap here to place this adapter for the antenna, so that's where the antenna screws in. It's going to go like this, and I'm going to solder the inside here. That's pretty ugly, but if it holds, it holds. So it's starting to look like a J-pole. The soldering seems to be holding at least, and it's pretty long. I have to clean my terrace. Very nice. Of course, I messed up because I should have put this cap here later. How am I going to slide my support here? Yeah, now I have to attach the wires for the feed point here and here. Alright, so I soldered the wires in the holes, and this is the central part with the BNC and the second wire, so the feeding point is right here. Just like that. So I had to cut my support here, unfortunately, but I'm going to epoxy it back on, and it should look okay. All that's going to be painted anyways. So here's how it looks like. Of course, I'm not going to test it like that, but the whip is attached and the total length is then 4.2 meters plus the handle. And right away I'm running into a problem, which is that the antenna is resonant, perfectly resonant with a great SWR at 53 megahertz. But in France, the 6-meter band stops at 52 megahertz. So I'm going to have to fix that somehow. Fortunately, the French antenna I have is 3.2 meters long, so quite a bit longer than the other one. And Bob's your uncle, resonant at 51 megahertz, smack in the middle of the French 6-meter band. Awesome. On my usual frequency of operation, 51.5 megahertz, the SWR is 1.4, which is good enough. Of course, I could have, adjusted the antenna to have a 1.0 or 1.1 to 1, but it really doesn't matter. All right, I sanded it. Now I'm going to wipe it with acetone. I better finish painting this before I can't see anything anymore. Paint everywhere. This is why I'm single, guys. I was lucky that my French antenna is 3.2 meters and not 2.85. So I can actually use it on pretty much the whole band, and 2.85 actually would be good for someone who's in the US because of course the 6 meter band is from 50 to 54 megahertz. So 53 megahertz is perfect. For me, no, because not so much. The French band for 6 meters is 50 to 52 megahertz. So I wanted to go a little bit lower, and that 3.2 meter antenna will do it for me. It's perfect. And for you guys in the US or anywhere else you have a little bit more bandwidth, you can use the 2.5 meter whip. And now I just have to take it to the field and test it with my VRM-5080. And I can't wait to see if it works. I know it's going to work, but you know, hopefully I'll make a couple contacts on 6 meter FM. Yeah. Alright, so ignore the trash. But the antenna is right there. And it's not exactly straight, but that should do. I'm going to check the SWR. Here's my operating position with my friends over there, and we'll see how that works. The SWR is 1.6 to 1, which is pretty good, and the scan shows that I am resonant actually on 51 megahertz, so not exactly on 51.5, but that's close enough. I had to make an adapter here because I needed the, well, at least 24 volts, and I made a series adapter for the Anderson power poles, so I could use my 2 battery packs here, and it should work fine. Here is the beast. CQ, 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 CQ. Ici F4 Whiskey Bravo Yankee. F4 WBY. Foxtrot 4 Whiskey Bravo Yankee. Over. It's gonna take a while. Unfortunately, as expected, although I was hoping still to make a contact on 6 meters FM, but it didn't happen as usual. And I know I'm a sucker for, you know, trying again and again and again, but I think that's the key. Is if I want to develop this frequency around here, is that I have to try again and again. And unfortunately, no contact, but the antenna works really well. I mean, as far as I can tell. So I'm pretty happy with it. I'm going to use it again in, you know, for portable operations. And I wish I had a whip exactly about 3 meters long. This one is 3.2, it's a little too long, but 2.85 is a little too short, so I think that 3 meters would be perfect. But hey, you know, it's good enough, so I'm pretty happy with it, and yeah, I consider that a success. Have a good one.